Hello, everybody, and welcome to Lecture 7. This is about effects processing. We're going to be looking about digital signal processing, or DSP for short, otherwise known as effects plugins, dynamics, EQ, and effects, which are the latter being just more about spatial processing, such as reverb and delays and things like that. And just a quick note that we will be applying all this to stem mixing. I'll tell you all about what that means when we get to it in Lab 4 this week. So here we go. Now, we've been working with kind of just volume and panning at this point, and some crossfades. We cheated a bit when we had some cave ambience, and we cheated a bit and used some reverb on an effects plugin. But other than that, we've had a pretty basic kind of mixing realm here. Now, what we're going to do today is learn about different ways we can process audio aside from just plain volume changes and plain panning changes in many different ways. So DSP, or digital signal processing, is just a group of effects and filters and other spatial processors that are designed to manipulate audio in some way. Sometimes you may hear terms like audio modulation, okay, or there's something called a FFT, a fast Fourier transform, that we can apply to certain effects. All kinds of fancy terms, but basically, we're dealing with anything that's going to be EQ or equalization, some form of echo or reverb, and other types of signal processors such as choruses, flangers, phasers. I'll try to cover as many of them as I can here, but the list just grows every day. There's new plugins. There's a lot of free plugins available that you can find online, and people are always coming up with novel ways to process audio and coming up with new terms. So it's a never-ending list. But we'll go over some of the more pertinent ones here. All right. Now, really, I want you to know there's three main categories of DSP. There's dynamics, which is manipulating volumes kind of across the board, louder or softer as time goes on. We have EQ, or equalization, which is about manipulating certain frequencies and turning the volumes up and down with those frequencies. And effects, which covers a much larger, it's kind of like the other category, and usually involves spatial mixing, such as reverbs, delays, echoes, and so forth. So let's talk about dynamics first. This is where we're just dealing with the control of volume over time, again, across the whole frequency spectrum, okay? And one of the things we can do is simply, instead of having an effects kind of plug-in, we can just process the sound as it is, kind of a before-after thing called normalizing. And then we have something a little more sophisticated, which is called compression. I'll tell you in a moment about limiting, which is just basically the really extreme version of compression. But let's talk about normalizing first. This is the easiest of the dynamics processors. Okay, we're just going to be increasing the volume of a sound clip to a certain level. All right, and the most common form of normalizing is peak normalizing. This is where we take a sound and we bring it up to its some peak that we set, and often that means the loudest possible decibel level we can have, which is 0, the digital ceiling. And what I mean by that is this. So you have on the left, you have this sound clip here, which looks like we've got a lot of what we call headroom, meaning there's kind of some wasted space here. We have the signal, but it's like we've got about minus 7 dB or so of kind of open air. So by applying a normalization, peak normalizing, it's going to take our sound and bring it up to some level. Let's say we set the peak to be 0. Well, it's going to peak normalize. So it's going to take the loudest point in the entire clip. It's going to look ahead and do some processing, do some math here, and say, okay, I've got a loudest point seems to be here, so I'll bring that up to 0, and everything else will linearly follow suit. All right, we're not doing any strange coloration to the sound or anything like that. Okay, it's just about 7 dB louder than the original across the board, which is nice. It's kind of like this kind of secret weapon you have for boosting volume, aside from using the volume control, We're just taking the internal the data, the sample information, and just bringing everything up, right? All the amplitude. But remember, nothing is louder than the digital ceiling, and I mean nothing. When you go beyond this, you're going to introduce clipping, errors, glitches, and Reaper will eventually be so forgiving and kind that it will actually mute the track for you if you get too loud. I don't suggest you try that because it may or may not work, but it is supposed to mute it for you. So anyway, nothing's louder than the digital ceiling. Now, if you were to go ahead and try this yourself with any audio clip that you may have, you can simply select it and then right-click Item Processing, and then either to the right or left window will pop up and it'll say Normalize Items. And this is just going to bring it up to, in this case, digital 0. Reaper just does it automatically peak to 0, but there are certain DAWs that you can set the threshold of this. But I'll show you what this looks like. So again, you have the minus 7-ish dB maximum amplitude here on the left, and then on the right you have the 0 dB ceiling, and everything's brought up. Now the second type is called RMS normalizing, and this is where we take sound and bring it up to some perceived loudness. This is not peak normalizing, okay? This is where you kind of feel like it's kind of set in a contour level that your ears feel like everything is generally the same volume, the same loudness level, okay? Now, usually we measure this at a much lower level. If you have a consistent decibel level, oftentimes less is more. So it's like minus 16 would be pretty loud music. And if you go beyond that, it would be almost overbearing, simply because there are no breaks. You know, it's just like this kind of brick wall that of dynamic range has been squashed. Much different than peak normalizing. Now Reaper doesn't have this feature. We have something kind of sort of like it in the compression plugin that I'm going to show you in a few minutes, but it doesn't have a formal RMS normalizer. And for all you math geeks, RMS means root mean squares, you know, and it's this process that really boosts the volume overall. Okay, so remember, peak normalizing is all volume increasing at the same level, right? And RMS normalizing means all volume increases are not the same. Okay, so here with peak we have a 1-to-1 increase across the samples anywhere you look. If you brought this up, you know, 7 decibels, 7.25 decibels, this will be 7.25, this will be plus 7.25, and so on. But here, with RMS normalizing, it's not the same. Right? It's a contour, because we're trying to hold to some perceived loudness. So this is 7.25, but this might be 12.89, and this might be 13.2, and so on. Okay. It maintains the loudness as much as possible. You can dial in kind of how strict you want to be about it, and whether or not you want to make the entire sound clip look like a brick, okay, which is kind of like the loudness wars in commercial music that have been happening for many years. If you were to import your favorite tune, if it's like a popular tune or something, bring it in the Reaper and look at the dynamic range, and you'll notice it's very brick-like, okay? It's been going on for years. Just how much volume can we get to blast through everything else on the radio? Anyway, a good plugin will allow us to loosen up that perceived loudness, as I mentioned, so it's more of a range than that brick amount, okay? Now, sometimes a signal has a very large dynamic range. And remember, the term dynamic range is the peak amplitude, and when we were talking about microphones, we said the noise floor, but in this case, it's the peak amplitude, minus the lowest amplitude. In this case, is minus infinity, and then the peak is 0. So we've got every conceivable peak and valley here, right? Some elements are too quiet and some are too loud. Let's pretend this is dialogue, all right? We could fix this by simply, shift clicking every point, from here to Sunday, or we could use the automation tool I showed you with latch and write, okay, and touch and all that. And that's actually a decent way to bring in a volume change here. But what if you've got 20,000 voice clips to deal with or something? Well, there is a better way. Unfortunately, we have an effects plugin we can use called a compressor. This is a tool that will turn down the volume essentially when a signal gets too loud, and that too loud being what you've wanted to define it as. It can also turn up the volume when the signal gets too quiet. That's another option as well. So we're keeping the overall volume level more constant, and we can kind of dial that in or out. How much we want to squash this sound clip, its dynamic range. Okay, so here's the in this kind of darker region here. I had some original sound clip, the one I just showed you. But then when I applied some moderate compression, look what happened. If I re-imported it into Reaper, I could see that it's boosted the low parts, but it's also kind of only boosted the high parts maybe a little bit. And so it's kind of more of a consistent dynamic range. Now your ears, I'll be showing you some of this in just a moment, but your ears would register this as kind of like a constant volume level. Okay. Now, if I added really, really heavy compression, it's going to look like this. We're getting to that brick wall I was telling you about. And this is what we call limiting. Now, there's no formal value in terms of like when does compression become limiting, but there is a certain ratio that I'm going to show you in the plugin in just a couple of minutes. And it tends to be when we get beyond a 10-to-1 ratio from the original signal, which is pretty dramatic, but we can go as high as we want. We can go to like 100-to-1, 1,000-to-1. It's all how much you want to squash the dynamic range and how much is actually needed to do that. Right. So compressors are going to work really great for you if you know how to use them. Now, I don't expect anyone to become a compression expert in like a week or even for the remainder of the course. It takes a lot of practice. There are whole books written on just compression, and there are even classes just on dynamics control, and it's not an easy thing, and it's just going to take practice and iteration, and every sound file, voice file, music file, they're all going to have different needs, and you may or may not need compression, but you'll find that it works pretty well just about everywhere once you get to learn how to use it. So I'm going to take you to Reaper now, all right, and let's take a look and see how this is going to work.